Greater than 1 or less than 1? Less than 1. So that means that this graph is decreasing. Okay, right away it's decreasing. Guys. Hey, can you be quiet? Okay, so it's decreasing. So the two possible graphs that are decreasing are which two here? A, B, C, or D? C and D. C and D are decreasing. You should be able to tell that by looking at the graph. Okay, so you should be able to look at a picture of a graph and tell me if it's increasing or decreasing. C and D here are decreasing. So it can only be C or D. Then the other number, the 3, what does it tell me? The y-intercept. So if I look at this, the y-intercept on D is 4, C is 3, so it has to be I. What I personally would do then, because there's only one decreasing graph left, I'd look for the other graph that must be decreasing. So if I look at 2, 3, and 4, which of those must be decreasing? 3. So this one has to be 3. Okay? Now, the other two, they're increasing. They're both increasing. So 1 and 3 are off. It's just a difference of the y-intercepts. So A would be what? 4. And B would be 2. So this would be, if it was on an assignment and it asked for the justifications, you would just say, like, it's decreasing and the y-intercept is 3. It's decreasing and the y-intercept is 4. It's increasing, the y-intercept is 2. It's increasing, the y-intercept is 4. So it's just identifying that you know that on those things, that's how it works. Okay, so that's just a little review from yesterday, because that's what we looked at, that the value A is the y-intercept, and the value B inside the brackets tells you if it's increasing or decreasing. Okay, that's what. Oh my gosh, oops. What we're going to get into today is solving exponential equations. You have to do them two different ways. You have to be able to do them algebraically, which means by hand. And of course you can use a calculator to do some of the calculations, but I would have to be able to see all your work. Okay, that's the part here that I would say is kind of tough. Okay, then there's solving using technology, which is using your calculator, which is pretty easy. Okay, as long as you learn the buttons to press. So we're going to do algebraic first, and it's really important that you kind of learn how to do this. It is a tougher part. Before we get into it, though, I'm going to review the exponent laws. So there's a couple exponent laws you're supposed to know. They're from when you were little. Okay, you were, well, not little, but littler. Okay, grade 9. Okay, so if you have a to the power of m times a to the power of n, does anyone remember what the kind of cheat is that you can do? Yeah, I hear somebody saying it, but they're really shy. It's m plus n. So you keep the bottom the same, a, and it's a to the power of m plus n. So that means if you have two powers, for instance, if you had something like 2 squared times 2 cubed, that is equal to 2 to the power of 5. Okay, that's something you've seen. Okay, you saw it in grade 9, and I'm sure you were great at it. Okay, then the next rule, also pretty straightforward, is if you have a to the m divided by a to the n, you do what? Subtract. So it would be a to the m minus n. Okay, so again, if you had something like 2 to the power of 8 divided by 2 to the power of 3, you would subtract the 8 and the 3 and get 2 to the power of 5. Okay, very simple. Okay, the last one that you're supposed to know is that if you have a to the power of m, and then there's an n on the outside, okay, like that, we call this power to a power. So we have a power in the inside, a to the m, and then a power on the outside as well. And does anyone remember what you would do with them? Multiply them. So it's m, it's pretty messy, m times n. Okay? And that's how this works. So it's pretty straightforward, these three rules. You have to know them because we're going to be using them. a little bit, and we're going to be using them a little differently than you've seen.
But this is a one chance only. There's a gray blue Caravan with license number CAME42 and a black Chevy truck with an Alberta license plate BNL 2799. You're parked in visitor parking lot at Welladay, and you only got about 2 seconds to get over there and move them. Otherwise, they're gone.
They already have the tow truck there.
Our paid spot. Yeah. No,
Okay, so we have here 3 power rules that you're supposed to know. My bad, guys. Now, the way that you solve these, okay, these kind of equations, does use that somewhat. So it also uses something you've never seen before. This is completely new, so you should pay attention and write it down, would be my suggestion. Okay, now, the other thing, actually, maybe I'll go back to the last slide. Or no, I'll just do it over here. Okay, the other rule that I guess you need to know that you've perhaps forgotten in since grade 9 or 10, if you have if you have something like, I don't know, 2 to the power of 3. Everyone knows what that is. Well, maybe not. 2. It means 2 times 2 times 2. What's 2 times to the power of 3? 2 times 2 times 2. 8. It is 8. 6 is a popular answer, though, anytime. So it's okay. But we're going to get more into this where we're doing exponents. So always check them on your calculator. It's super easy to accidentally just multiply the exponents, like by the number. It happens constantly. It happens to me. So try not to. Now, 2 to the power of negative 3. That's a little weird. Okay, it's a little bit different. I don't know if anyone remembers what 2 to the power of negative 3 would be if 2 to the power of 3 is 8. It's not negative 8. It's not just 8 either. It's actually 1 over 8. Okay? Which is a little weird. So if you have, and that's just a rule you learn in grade 10, and you have to work with it quite a lot in grade 10, that a negative exponent means, it actually means reciprocal technically. So if 2 to the power of 3 is 8, 2 to the power of negative 3 is the reciprocal of 8, which is 1 over 8. But it's something that you did quite a while ago. So, for instance, let's just do another one really quick. If I have 5 squared, that's 25. People generally know that one. Okay, if I have 5 to the negative 2, what would that be? 1 over 25. Okay, so I just wanted to briefly go over that because you do need that for this question. And a lot of these questions you'll need that. So I have here 2 times 4 to the power of 2x is equal to 1 over 32. Okay, now doing this by hand is pretty hard. And what you have to do is first you have to isolate the power. Okay, so the power, that's the first step in these problems, isolating the power. So the power is this part. Okay, that's the power. And what you cannot do, and what I guarantee I'll see people doing in about 20 minutes when I give you time to practice on this, is people will go 2 times 4 is 8, and they'll get 8 to the power of 2x. You cannot do that, okay, because you have to follow order of operations, so you can't multiply before you do the exponent, okay, which is, BEDMAS. So you're just not allowed to do it. So focus on isolating the power. So I have 2 times that power, so how would I get rid of the 2? Divide by 2. Okay, now if I divide 1 over 32 by 2, that is something that I would expect that some people might not feel comfortable doing. They wouldn't know what it was necessarily off the bat. You could think of it logically like half of 1/32. Okay, like 1 over 32 means 1/32. A half of that would be a 64th. Okay, you can think of it logically. It's easier with smaller numbers. Like if I'm dividing a half by 2, it's more obvious that that's a quarter, because half of a half is a quarter. Okay, once the numbers get big, it's harder. You can also use your calculator. Okay, so just type into your calculator 1 over 32 divided by 2, and then use your calculator to turn that into a fraction. So hit math frac, the first option there, and it'll turn it in. So if you'd go, try it right now in your TI-83 or 84 if you have one, go 1 divide by 32, divide by 2, and then hit math fraction, and you'll see it's 1 over 64. Oops. Or you could use a fraction, like use a fraction, the fraction template on your calculator to do 1 over 32 and then divide by 2. It'll give you a fraction right away, which is nice. Okay, so whatever you want, but use your calculator for this stuff, because what I sometimes see is people do things like they'd write 1 over 16 because they think I'm dividing 32 by 2, and then you'll end up getting the rest of the question wrong, okay, which is, unfortunate when it happens, but it does happen sometimes. Okay, now this is the tricky part. Getting that shouldn't be too tricky. Use a calculator. This is the tricky part. You have to do something that we call writing the powers in the same base. So generally speaking, it's going to be the base that's here. Does anyone know what the base of this power is? The 4 to the power of 2x. What's the base? No. Okay, so if I'm looking at this, what would I say the base is? 4. The base is 4. It's the big number. Okay, so what you're doing here is you want to write 1 over 64 as a power with a base of 4. So this is what I personally do. I write it, I'm like, okay, I have 4 to the power of 2x equals, and I want this to be 4 to the power of something. Okay, so I need to think about what is going to give me 4 to the power of something that's going to give me 1 over 64. And this can be tough. You have to use your calculator a bit if you're not very good at powers, and I'm thinking nobody in here is probably like amazing at powers. Like, I don't know if it's any of your guys' like passion. I'm not that great at powers, so I have to try them on my calculator a lot. So what I do is I just go, I'm like, okay, well, 4 squared is 16. I know that one. 4 to the power of 3 is 64. And I just try it on my calculator. Okay? So these are going to work. If you're asked to do this algebraically, they're going to work out. Okay? So 4 to the power of 3 is 64. So what would be 1 over 64? Negative 3. So I put negative 3 up there, okay? Because if 3 gives you 64, negative 3 gives you 1 over 64. Now what you can do, once that base is the same, you can cancel it off, and you're just left with 2x equals negative 3. Ooh, my gosh, my stylus is really not into it today. Okay, so 2x equals negative 3. Then how do I finish that off? Division. I just divide both sides by 2. Okay, so all I do is divide by 2, and I get x equals negative 1.5. Okay, and I know it's a little down there. I'll try to lift it up here. X equals negative 1.5. That's what I get. And how could I check this? Yeah, go back up to the start. So the original equation, remember, the very original equation was 2 times 4. Oops, that really looks like a 9, so I'm going to redo it. 4 to the 2x equals 1 over 32. And what you do is you plug the negative 1.5 in, and you should do this. Very few of you check your work. I can tell when I'm marking it. You really should be doing this on every question. So you just type into a calculator 2 to the power of 4 2 times 4 to the power of 2 times negative 1.5 or negative 3, and then check that it's equal to 1 over 32. And you can do that on any type of calculator. I can do it on my scientific calculator here. 2 times negative 1.5. I get 0.03125, and if I type 1 over 32, I also get 0.03125, so I know it's correct. Okay, and you don't have to write that down usually anyway, although I don't even ask for it here. I have sometimes asked students to show their check, but you should do it on every question, whether or not I ask. Okay, it just takes an extra second. Okay, so this is another thing that you probably don't remember from from grade 10. It's a lot of grade 10 stuff that's being reviewed here. In grade 10, you learn how to write a square root sign as a power. I don't know, does anyone in the room remember how to write a square root sign as a power. It's okay if nobody does. I'm not too surprised. It's not a super useful skill that comes up every day. Okay, so a square root, I can rewrite it as a power. I'll show you how. Instead of a square root, I write 125 to the power of 1/2. Okay, and that's the same. They're equal. If you try it on your calculator, if you type in the square root of 125 and then you type in 125 to the power of 1/2, you'll get the same answer. Okay, so that is something you're supposed to know for this unit, so it's great that we're going over it. Okay, and then I have 5x plus 2. So now it's always the same thing with these. You always want to come up with the same base. So I have 5 on this side. It went back like super far. Okay, so what I want is to write 125 as a base 5. Okay, so let's try on our calculators right now and let me know when you got it. 5 to the power of something, I want to put a number up there to get 125. 3 works. And these numbers are never going to be super high. Like, it's never going to be like 25 or something where you have to keep guessing. It's always going to be like a number between 0 and 8, probably. So, pretty straightforward. So it's 5 to the power of 3. And then this is where it's a little weird because that 1/2 is there. I need to put that on the outside. 1/2. Like that. And this is when those power rules come into play. Because what was the rule for power to a power like that? Multiply. So I can multiply those out. So I have 5x plus 2, God, it's like the slowest in the universe, equals, what's 3 times 1/2? 1.5. And I'm totally fine with using decimals and stuff. Now, once we have the 2 5s there, what can I do? Cancel them off. So I cancel them off. Canceled, canceled. And I'm left with just x plus 2 equals 1.5. Okay, now what do? Take away 2. So I subtract 2 from both sides, and I get x equals negative 0.5. Okay, and that's everything. And it's pretty easy. This is, I think, personally one of these things where when you watch me do it, it looks pretty simple. But when you try to do it yourself, it's much harder. So don't worry, when you first start these, they'll seem tough, but eventually they'll feel easier. It's always, always, always finding a common base, though. Okay, so here, that's how it worked. First, we figured out a way to make it both power of 5. Then we could cancel off the 5s. Okay, so let's look at the last one here. Okay, it's a little bit trickier. Try to get it up there. Okay, so it is a little bit trickier because there's x's on both sides of the equations. Quite a panic if that's the kind of thing that freaks you out. Okay, but it's actually not too bad in terms of writing them as a common base. It's always going to be the lower number that stays. Okay, so the 3 is fine. The 3 and the x minus 3, that's fine. The 9, I can very easily write as a power of 3. 3 to the power of what gives me 9? 2. It is 2, not 3. Okay, 3 times 3 is 9, but that means 3 squared is 9. So it's 3 squared instead of 9. So I put 3 squared. This is the part that people usually get a little confused at. What you do is you just put brackets around it, because that's the 9. And then you put the x minus 1 on the outside of the brackets. And actually what I often encourage students to do is you can even cancel the 3's right now if you want. You just have to remember that that 2 in there doesn't cancel. It multiplies by the x minus 1. So you put the x minus 1 in brackets like that. Okay, so it's actually quite simple. Now what would I do if I want to solve this and figure out what x is equal to? Expand, yeah. So I'm going to expand. I get 2x minus 2 equals x minus 3. Okay, and now what? Move everything to one side, or you can think of it as moving all the x's onto one side and all the numbers onto the other. Whatever method works for you. At this point, though, you do want to combine those x's for sure. So taking away an x from both sides would work well. If I take away an x from both sides, I get x minus 2 equals negative 3. And then it's pretty obvious. I add 2. So if your algebra, your basic algebra is weak, this kind of stuff can be hard. But just, you need to practice is the thing. Okay, so a lot of your algebra is actually quite good. But if this kind of stuff feels a little stressful to you, just ask me for some help on it. I can help you out, and it'll just take some practice to kind of reawaken the spirit of this. Okay, but that's how you do it. And then you plug it back into the start and check that the left side is equal to the right side. Okay, all the time. Okay, so these ones, when it says algebraically, you have to find a common base. That's pretty much the only way to do it. Now, not doing it algebraically, I'm skipping the slide in the middle, by the way, with the word problems. We'll just focus on word problems afterwards. Here is an equation that you could not possibly do by hand. Okay, I could not do this algebraically. I mean, I could, but you guys can't at this point because you don't know logarithms yet. Okay, so instead you need to use a calculator. I can tell right away that this one can't be done by hand. Does anyone have an idea of how I can tell? Yeah, 5 is not possible. Leon just said 5. 2 can't go into 5. Like there's no 2 to the power of that's going to give me 5. Okay, like 2 squared is 4, and 2 to the power of 3 is 8. So I couldn't possibly put these with the same base. And that's when we end up with the problem, and we have to do it on our calculator. So I'm going to word number. I know that 4 can be rewritten as 2 squared. Okay, and then that would be the same thing as 4. So I can replace 4 with 2 squared, and then 32 is 2 to the power of 5. Okay, and then I can do the same thing. So I can cross these off and have 1 minus 2x equals 5. And you can do it out that way. Either way, if you realize that 2.5 works, that's fine. You get a right answer, so I'm happy with it. Or do it this way and end up getting negative 4x equals 3, so x is negative 0.75. Okay, so however you choose to do it, okay, is good. But that's how these ones are really supposed to be done. I just want a written response question before the end of class, and then we'll finish. Tomorrow, or not tomorrow, Monday, we'll be practicing these. We'll have a quiz Tuesday on what we've done up to now. I know it's very short. This is a very short unit. There's only one more section after this one. And the last section is on regression, which is identical to what we did last unit. So it should be fine. We're very close to the end of the unit. And this unit and the next unit tie together a lot. So anyway, this question is a half-life problem. They show up fairly frequently on the departmental exam. And they're just really common types of problems for both this unit and the next unit. So try to understand it. It's a little bit confusing. We'll practice them so that hopefully you can kind of like get the hang of them, just because they are quite common. So this says, when diving underwater, the light decreases as the depth of the diver increases. On a sunny day off the coast of Vancouver Island, a diving team recorded 100% visibility at the surface, but only 25% visibility 10 meters below the surface. The team determined the visibility for the dive could be modeled using a half-life exponential function. So a half-life function, usually actually, this is it's not completely weird, but a lot of the time half-life functions get used to talk about radioactive decay. So, for instance, if you ever have read about like Chernobyl or other radioactive spills, the way that radioactivity works is like it stays in the environment for a long, long time. So we'll often talk about half-lives there. A half-life is how long it takes for half of something to be left. Okay, so for instance, if you had like, a lot of the time these questions are things like you have 5 grams of uranium and the half-life of uranium is 25 years. That means that it takes 25 years for half of the uranium you have to be gone. So if you started with 5 grams, after 25 years, you'd be down to 2.5 grams, because that's half. And then in another 25 years, you would have half of 2.5, so 1.25. And it would keep halving, but every 25 years. Okay? Now, this is the formula that gets used for this. So this is important to know the pieces to this formula. A with the 0 next to it, that's usually referred to as A naught. Okay, I'll actually zoom in a little bit here. A naught is the initial amount. So in that example I just said, where I said we start with 5 grams of something, it would be 5. Now in this question, we're talking about a dive and visibility. And it tells us that they start at 100%. So here, A naught would be 100%. Okay, it would be 100. H stands for half-life. Okay, X is is time, and it can be whatever unit we're using. So in this case, I actually can't remember the question, but oh, 10 meters. So in this case, it's actually not time. It's usually time. In this case, it's going to be distance. So I'm just going to put / distance, because we're talking about meters here. Usually it's time, though. It'll be like, how much uranium is there after 320 years or something, and you could calculate it that way. And A, the final number here, A of X, this is the final amount. So A stands for amount. This question's a little atypical because you kind of need to come up with the formula yourself. Generally speaking, the ones I've seen at the 30-2 level on the exam have generally speaking given you the values, so you haven't had to come up with them yourself. But we can come up with them together because I'll tell you. Okay? So here, the question is, at what depth will the visibility be half the visibility at the surface? So really what they're looking for here is they're actually looking for the half-life. So they're looking for H. They want us to tell them what H is. So the question is here, what is H? Okay, that's the question that they're asking us. So in that equation there, what's H? So what that means is we have to fill in everything other than H. We have to fill in everything other than H. So we have quite a lot to fill in. So what we're going to be using here is the 100% as the initial. And then we're also told an amount. So we're told that at 10 meters, so that's our X value, there's 25% visibility. Does anyone have an idea of where the 25 would go? AX. Of AX, that's absolutely right. So that's what we're going to do. We're going to plug all that stuff in. Okay, so we're going to have 25 equals 100. The half doesn't change here. The half is a half all the time when we're doing half-life. X, I told you, is 10, and it's over H. So that's the formula we have here that we're trying to solve for. Okay, and this is kind of an atypical one. Now, we can actually do this one by hand, believe it or not. We do not need a calculator. You could, of course, use a calculator. I very rarely, with the word problems, will say you have to do them by hand. In fact, I don't think I ever really say that. So you can pull out a calculator and do it that way if you want. So you could make 25 equal to y1 and the right side of the equation equal to y2 and find where they cross. But this one is doable by hand. So I isolate the power. So first thing I do here is divide by 100. So if I do that on both sides, I get a quarter is equal to a half to the power of 10 over H. Okay, and one's a little bit tricky, but there's more than one way to do it. You could think of a quarter as a half squared, because it is. That's what a quarter is. It's a half squared. So you could write it that way. You could also write it as 2 to the power of -2, and then write a half as 2 to the power of -1. But personally, I would have probably done it this way. I would have been like, a quarter is just a half squared, okay, and knowing that, because it is, okay, they're the same. And then we have a half to the power of 10 over h, and then just like the ones we were doing before, those are the same, so I can cross them off. So I get 2 equals 10 over h. And then I have a whole bunch of grade 12 students panic because they don't know what to do. They're like, what do I do with the h's on the bottom? Or I get a lot of people who are like, it's 20, which doesn't actually make sense. Does anyone know what h would have to be here? You kind of like cross multiply, yeah. So that's one way. If you put this over 1, you can cross multiply these, and you can get 2h equals 10, and then h equals 5. Or you can kind of like use your brain a little bit. I know that some of us avoid that, but if 2 equals 10 over h, okay, you think 10 divided by some number is 2. Okay, when you're doing algebra, a lot of people get really too into their heads about the steps that they're following, and they're like, I need to follow the steps, I need to do inverse operations, I need to subtract or add or whatever. But also use some logic. I know that 10 divided by 5 is 2. So I know that h is 5. You know, I don't need to do a bunch of fancy math to figure that out. Okay, I should just be able to look at it and kind of know that. So however it ends up working, but you do get 5. So here that means that every 5 meters, the diver will lose half of their visibility. So not, what happens is sometimes people, I don't know, people get weird ideas about that. If we made a table of values for this, and that does actually sometimes help here, what that means is that if we start at 100, after 5 meters we're at 50, then at 10 meters, what are we at? 25. Then at 15, does anyone know what we'd be at? 12 and a half, yeah. You had the right idea. Okay, and then it keeps going. So 20 would be 6.25. So it's every time it's halved. Okay, that's how this works. So it's going to keep being halved forever. Okay, it's technically like, you know, you get to like 99.9 or whatever, like 0.00, you get really small. But these tables, if you understand half-life and actually understand it, these tables can help on problems, especially on multiple choice problems and stuff, because you can kind of reason out the answers. So we're going to see a bunch more half-life problems. That's one typical type of problem in this unit. The other type of problem that gets used a lot in exponential functions is interest and interest rates, and talking about cars and car payments, stuff like that. So we will be doing some financial mathematics over the next week. People always say they want to learn more about it, so I'm coming with some finance stuff. It's not that interesting, to be honest, but we'll do it. And that's the main thing. So there's a couple different word problems that we need to know. This is one of them.